one, we're going to find the slope of the polar curve. R equals cosine of 2 theta at each indicated point. That's 0 plus or minus pi divided by 2 and pi. To do this, we're going to find the derivative of y with respect to x. And for us, that means it's going to be the derivative of y with respect to theta divided by derivative of x with respect to theta. So what you're going to do is look at your y. Our y equals r sine of theta. Now for that, we're going to go ahead and substitute in our r, and this is going to equal cosine of 2 theta times sine of theta. Now let's go ahead and differentiate our y with respect to theta. So we're doing the numerator part. That's going to give us, let's see, take the derivative of sine, cosine of theta. We're just using the product rule, times cosine of 2 theta, and then differentiate your, let's see, we're going to keep our sine, and derivative of cosine is negative sine, and then we have 2 theta. And then you have to do the chain rule and put the 2 in front. So there we go with that. Now for the derivative of x with respect to theta, we do the same thing. X equals r cosine of theta. Using substitution, this is going to give us cosine of 2 theta times cosine of theta. So let's differentiate our x with respect to theta. And this is going to give me negative sine of theta times cosine of 2 theta minus 2 cosine of theta times sine of 2 theta. Just using the product rule there. Same thing, it's very similar to this one. All right, now let's put it all together. And we do that, we're going to get our derivative of y with respect to x equals cosine of theta cosine of 2 theta minus 2 sine of theta sine of 2 theta divided by negative sine of theta cosine of 2 theta minus 2 cosine of theta sine of 2 theta. They all look alike after a while. All right. So the first thing I want to do is just check 0 and pi. And the reason I want to do that is if you substitute in 0 here and here, this is sine here, you're going to get 0 minus 0. So you're going to get a 0 in the denominator. And the same thing happens when you substitute in pi. You're going to get 0 minus 0, which is just 0. So basically, when theta equals 0, it's going to be undefined slope. Same thing's going to happen with pi. You're going to get an undefined slope. So now let's just worry about theta equals pi divided by 2. So for that, you substitute in pi divided by 2. You're going to get 0 for this piece. So let's do this. You're going to get 0. And this piece here is going to give you negative 1. Then you have minus 2 times 1. But then you're going to get 0 again. So in the numerator, you get 0. For the denominator, you're going to get sine of pi divided by 2 is, we're doing negative right now. So that's going to be negative 1 times negative, so that's going to be 1 times negative 1. And this right here is all going to go to 0. So we get negative 1. This equals 0. So at theta equals negative pi divided by 2, our slope is 0. Now at theta equal pi divided by 2, we're going to get 1 and negative 1, I believe. But anyway, we're going to get 0 because you're going to still have 2 zeros here. And the denominator, you're just going to get 1. So this is also at 0. So there's your answers to the 4 slopes you need at these points. 2 undefined and 2 at 0. Thank you. Have a nice day. Bye-bye.